this. Yes, here's mine in class. Here's my, and as I'm flying around this thing, let me know if there's any questions on yours. So I've used that template that's on, and I've just pulled that in, made it, and in my video, I make a couple copies of each sheet. So that's how I do it. I made my copies before I had them detailed out. So I had just blank sheets to work with, and place my parts list, and then I refine my parts. And I did show that, right? So the biggest thing in me is I refine my descriptions, and I even refined a couple of my part numbers I didn't like. If you still have the snap ring part numbers, that's okay. It's not going to be the end of the world. Like probably in a lot of working environments, the part number in your place of work, they may be like a kind of a sequential number or a coded number, and that's kind of what mine look like. I have that CAD 1122 in front of them, and so. And so that's kind of the only reason why I refined mine, but not the biggest thing. And also that I wanted my description to probably carry, that it's a McMaster car part and its part number in it. And so I just did a little bit of adjustment in my eye properties and my parts to get those to work out. And I actually made some new parts and swapped them out with the names I wanted.
What if when you make copies of your sheet, there's a little lightning bolt next to them?
Oh, that's always just like an update. And generally it's like you always get those like well, I think sometimes when you save it, that will be one thing that turns it off. But if you yeah, usually if you just click your like even mine says I have an update, but nothing's really updating when I click these updates. But yeah. I think that's pretty normal. Yeah. Even if I make a copy of mine, copy this, paste it. Let me see. Yeah, it does. It just gets like it's this new thing. I think when you click on it, if I double click on it, now that goes away. It's like it's recognizing that it's an active sheet now. And then you can change the name of it, of course. It's always gonna say copy of or something, or it's gonna yeah. And I've been changing those right here in this edit sheet. This is where I've been changing my name, and this name is then populating on my title of my sheet right here. That doesn't have to be that way. That's just the way this template is. You can actually, you can choose to pull these when you get really into the weeds of formatting your, just like we did with CAD a little bit. We just barely danced around it, and it's just how to format a template. It's a pretty deep study here in Inventor as well, or Revit. I don't know how much formatting of your templates you guys did in Revit, but they are pretty deep studies to figure out where you want to pull the information from. There's a lot of options. This one just happens to be pulling the title from right here. So I don't really need that sheet though, so I'm going to delete it. The template itself only has a single sheet, so it's just kind of ready to like make a bunch of copies of sheets if whenever you need. And I only needed 3 sheets, but if you needed more sheets than that, that's okay too. Like this was just where I ended up. And even if some of your views are different than mine, that's okay as well. Like this is just a general view as long as I can get to the parts list. And so if I'm going to refine these dimensions just a little bit, like I'm gonna open up the part and just check that, and I might add this. I think I've added what I say 15 thousandths to this bore is what it should be. So this one for me is not coming up maybe as accurate as the model shows. So let me open this part up and take a look at it. I can just like highlight it and open it from the drawing. Here's my part.
If your part is like that on the drawing, how does it flip it over?
If my part is like this, upside down. When you go to place a part, like here, I'll even bring in that part over here because if I just look at this thing for a second, come back to my drawing, and I go to place the base view, whether I go to like this base view or if I just right click and go base view, it's going to come in like however it is too. And I think mine's like yours, and it's because it's just how the part was originally drawn, even from the chapter exercises. And so, yeah, if this is upside down, you have this that you could flip around right now when you go to do that. When you go to place it first. Now, if you've already placed it, that's one way. If you have a little more options when you first place it than you do once you've placed it. So let me cancel that. Now, once I place it, if I want to edit that view, then I can come in here and say edit the view. And I will, oh, maybe I'll get the full navigation wheel. Yeah. So maybe it won't matter too much if I get it right the first time or the second time. But you have your this thing to rotate it how you want it. Even if it's all dimensioned out, they'll try to follow themselves around. Generally, like if I try that right now, if I needed this to be the other way, I think my dimensions will try their best. and all my views will change and everything, but I might have to do some refinement with my dimensions and maybe some deleting and removing or whatever. So, that's what I'll do and then try to reorganize it. If I don't get my stuff placed how I want it at first, yeah, definitely modifiable. Good question. Shoot out other ones that you have while we're talking here, because I know if you haven't watched all the videos, it might be a little confusing. But what I'm kind of doing is refining maybe this dimension here. I'm just going to check the tolerance. That's one of the more critical dimensions here. Obviously, the heights were critical. The different height in the like so this 1.59 versus this 1.41. Those are pretty critical heights too, because those connection rods have to be in plane, just off, their thicknesses off from each other so they can, actuate those pistons. So those are critical dimensions. I definitely would, recognize these as being really critical to the whole function and this bore diameter. So all I'm doing is I'm coming over here and I believe that I did these. I'm going to check my sketch just so I know. I guess I could just pull up the dimension, but when we did that extrusion of first, I've since changed it. Let me open it and just see what I've done. Mine's a little bit of an equation here, but it was 2 inch down to, and I could refine this too. Like this, once I finish a model and this one I was scaling down from another one, and now I have it. I could refine this if I want to. I mean, this still works for me. It's giving me the correct dimension. I thought that I had this larger. Um, Maybe I know it's on my real. Sorry, I have two models. I think I mentioned this yesterday. This is still going to be at the same tolerance that we did originally, which is what's on my drawing. I'll show you what actually ended up working. I'm going to stand by for just a second. I'm just going to open my other model. I have a pre-made model. It's not the one we did in class. Oh, heck yeah. Stop sharing. Yes. Sorry, I thought about you too, Sella, and then I forgot about you as I got it. But I have another one here. Let's see. I just don't think I have drawings for my other one. I think the only ones I have drawings for are the ones we did in class. So but I have this is the one I've actually 3D printed. It's just slightly different. Let me check its size. This is the one that definitely has the size that I want here. So if I see here, 1.5 inches is what is, scaled down from the original or the original book exercise of 2 inch is 1.5 inches. And then I've added 15 thousandths is what I've got. So that's really my actual dimension there. It would be like 1.5150 is essentially what my dimension should show on my print. And really, I need to fix that on this. So you probably are like mine on my actual one that I used. I need to refine its size a little bit here. So that's what I'll do. I'll come in here and I'll say, well, after printing, I learned a little bit about my printer and that 15 thousandths works best. So I can just refine this dimension and say it's actually 1.5. That's 75% of 2 inches. And then I can just say plus, instead of having necessarily an equation here going on, I can just say plus the 0.015. And that's the 15 thousandths that this should be. And I'll finish that. Yeah, mine's 0.0. That's my 15 thousandths is how I'd read that. But yeah, that's about how big I had to go. That's really big. Like I said, if it was metal, it might be 2 or 3 thousandths. I actually don't know what the tolerance for piston to cylinder is. In a car, they call this the piston case. The bore of this, you might have heard referred to as a cylinder in a piston or in a car assembly. Cylinder and a piston share the relationship that we have here. But I don't know what the I mean, if I Google it, it'd probably show me. I don't know what the tolerance is, but it's what is that? I actually have I have my actual dimension, which is 1.5 inches plus 15 thousandths, 0.015. Yes, and I'm gonna just make sure the other hole maybe is just even the same dimension as this. So once I apply this, I'll finish this sketch. I don't know if I tied them together originally, but I can check. Like this one here is my other hole. This sketch. I think it was. So me, I'd have to go if you didn't do it like I did it, if I'd have to go into this sketch and just make sure that this dimension is the same. I have it. It's D6. Now you might not know if you have a dimension in here and it would be the same. It'd be 1.5 plus 15 thousandths is what I kind of want to end up with. And if you don't know what your other dimension is called to even be able to call it out here, because this is how I would tie it to another dimension, D6, little lowercase d and 6. You'd have to know which dimension it is. Yours is probably not D6, because what I found is it's in the list here, right? As your on your quick access toolbar, here's your f of x, all of your dimensions in this part list, which I haven't named my dimensions either, so it's not easy to pick out of this list, other than I know what the dimension is. It's inch and a half plus 15 thousandths. And so it really is D6 here. So this is how I tied them together is I entered D6 as the dimension. Now when I change D6, the other board changes. So currently they're both the same. So I'll say done here. And I think the other one that I said is definitely a critical dimension on this. I mean, they're all pretty critical, but the ones I definitely want to maybe change their precision of on my sheet would is definitely going to be this to show its full size. And potentially this one, even though this isn't the one that's on my, this isn't the one that I've used on my sheet, but this is the one that's controlling the height of that. So that's a 0.03125. I might want to just be aware that I need to probably carry this many decimal places to get this height correct in the assembly. I know that's a lot of decimal places. That's actually only 1/32 of an inch, 0.03125. It's actually a pretty common decimal fraction, uh, even though it is out to 5 decimal places. So I think I'm going to carry 5 decimal places on that placement on my drawing. So I'll finish that. And then this one here, and this is arguable whether I should or not, or just carry 4 decimal places or 3, but there's definitely some rounding going to happen if I don't hit these dimensions. The other one is just how this one was originally drawn and where that bore height is, which I really don't have a dimension in my actual model that's there, but it'd be from here to here is on my is the dimension I'm looking for on my drawing sheet. And oh, we did show this, right? Maybe when you're doing your measurements, I just did a quick measurement there. If you don't have all these expanded out, I'm not sure how your dialog box is open, but it's this advanced properties down here where you can push the uh your measurement accuracy. So right now it's 4 decimal places. Here would be 5 decimal places. 4625, 40625. It's also kind of a 5 decimal place. I think it terminates after 5. Yeah. 40650. So it really is 5 decimal places. But usually when I'm doing my measurement, I probably am set to 4 decimal places. Um, and just because like a lot of common measurements are 4 decimal places, like 16th, 3/16ths. Any of the 16ths need 4 decimal places to show their true value. Eighths need 3 decimal places. Half and quarter needs 2 decimal places. Half just needs 1 or 2. But so what I'm saying is I like the size of this. The other thing we did, and maybe I didn't do it on camera at all or on film, as if I was running an analog video recorder back here on my digital recording. I did change the material to ABS plastic, right? So I changed it here on the quick access toolbar. I didn't change, I just let it take whatever just default color. I just left it with that. And I did show that in the eye properties here, this is the part eye properties, that I haven't really done much here other than I added description ABS plastic because that shows up in my drawing. Just because the default parts list in a drawing is pulling this description as its description column. But you could change you can change that. I mean, that's back into the template and formatting. You could change how your columns are where they're pulling their information. And then I kind of skipped these next 3 and I went to physical. And then I think this will already be, if you've chosen it in the quick access toolbar, it should be chosen here. And then this is where if you say update, it actually gives you the weight. Of course, it thinks that it's solid, so that could be different than how it actually prints. So I'll just close that though. So those are the modifications I made to this part. I made the plastic modification to all of my parts. And if I'm thinking of the dimensional changes I might make, then it's this one here. I think I'm going to pull like those 5 decimal places here. So if you just highlight the dimension, it has what? Precision, kind of like CAD did. CAD was able to do this as well. You know, I don't need that many decimal places here, I guess. If I'm dropping those zeros if I can. So I would say, oh, let's drop those zeros, those trailing zeros. I only need technically 3 decimal places. 5. Now, in a real drafting setting, we'd probably say this is 1.5 plus 15 thousandths minus 0, or something, but that's not exactly accurate because I really need it to be this and then maybe plus 1 or 2 extra thousandths and minus none from here because I don't think I get good functionality any less than this. So this is kind of functioning as a basic dimension to me. Like I've already toleranced it, yes, but this is actually my baseline of what the size I need, at least for 3D printing, right? And that's the other caveat we have here is that we're sizing this for 3D printing and building our model to reflect that as well. But in those early drafting stages, this might be what we're used to. Just at least call out the dimension it is. That's good. In reality, I might want to add a couple thousandths and minus none as kind of a unilateral tolerance, or maybe it's bilateral only there, I guess. Only in one direction. Unilateral. Yeah, bias two. There we go. I'll get my so a unilateral dimension. And then I just think I'll change this one, but this one is out to 5 decimal places to show uh to show its which seems like aggressive to me. I don't know. But that is the true dimension. And so it is kind of a basic dimension at that point. If you round it off at all, you might get some interference with how those connection rods are plainly, aligned. And that was this way too on this one. Oh, I guess, oh, well, there's another way you can do it. So you can just single select it. If you double select it, you can get in here to the precision and tolerance and change it here as well, right? So this is super manual. I could definitely do what I can in CAD and build a dimension style to apply as well. And maybe we'll explore that on another drawing. This one here I don't know if I can match properties. Can I? I don't know. Sometimes if I grab this one, copy properties. I think so. Copy properties. So this is maybe my match. Yeah, my match properties. So that works too. It works well. Where I don't have a match properties on my toolbar like I do in CAD, I definitely have at a right click menu here, copy properties. Pick a dimension, then you can go snapping through and apply and copy those. I don't know why they didn't call it match properties, but they decided not to. Oh, it's copy properties. So once you've changed one that you like, uh, it's right here, copy properties. I can use as a match properties. Now, if I copy one with a diameter sign and I apply it to one that I don't want a diameter sign, I don't think it affects it actually. So it's smart enough to know. And the only ones I really changed on this were those two dimensions. And I'm going to change this hole as well. I think I need to tolerance that hole. So I really have just added some extra careful dimensions to the through bore and their heights where they're aligned. Maybe that's my most critical stuff, except for the hole as well, which is this hole. Let's see how. I think I told you go out 10 thousandths on these. Let's just see if I was right. There, I have my extrusion here for the hole, and we'll take a look at it, and maybe I'll fix it up a little bit. Oh, I forget. This is still the. Let me check my other one. I'm pretty sure that's the one I haven't really changed yet on my actual drawing, but this one I have changed. Yeah, 10 thousandths is how much I've added to this. So this is it's for a 3/8 pin. The crankshaft is 0.375 in diameter, but I need about 10 thousandths to not have to do much cleanup to just drop that thing through. So I need it out to 3 decimal places then. I think I've got to fix my dimension to match this one. So I'll go into this piston case. Oh yeah, let's do that. Thank you. No, you can't see anything that I'm doing, but I am moving along. No, you're good. I'm still on the same part. I haven't made any. I'm just ready to change. Oh yeah, let's go in and change it. So I'm back. And so what it's going to be is I find my sketch here, go into my sketch. Let's fix this thing. So instead of being my weird equation, I'm going to say the real, that's the real dimension, 0.375. And then I'm going to add my tolerance in here, which is 0.1. Oh, sorry, 0.01, 10 thousandths. It would look like that if when I call it 10 thousandths, it looks more like that, but 0.01 is 10 thousandths. That's probably, as I go to use my printer or our printer here, it's like probably for hole to shaft, like for bolts and stuff. I'll remember that, 10 thousandths is probably the best tolerance, at least with this ABS plastic that I'm printing right now. And I think, it was a really, like when I Googled it, this is the difference of Google to a machine. It doesn't know what machine I have or necessarily what my material. It's just giving me kind of a ballpark. That was my 0.0008, and it was way too small. I needed much more than that. Okay. For some printers, that might have been good, but not for mine. So that's finished. And then I'm going to update this. I'm back over to my print really quick is what I did. And it's going to accept that. Other than I just need to double check here and change this precision to out to 3 decimal places. So whether I just copy one or if I just spot change it here. 385. Yeah, I think that was it. I don't think I need 4. Yeah, just 3 decimal places. And now that's calling out the correct bore size there. All of these would probably need refined in reality. I'm just trying to like pick a few basic ones, maybe the most function driven ones. So I'll save that real quick. I've done a little bit of work. It's going to save that part. I can close that part now. I've done the modifications that I want, so I'll close it. And maybe I'll move over to this part. Yeah, I'm just on my first page. Yeah, my first page is asking for an update, and if I click on it, it will update itself. It just knows that I've changed parts in the assembly, so you just watch for those updates. Yeah, generally, if you go to save here, it's going to want to update those too. So, okay, so then this one I do need to refine the through hole. Well, yeah, nothing, only just the hole through to accept the wrist pin here. So I'll open up this part. Oh, and so I did go like on my video, I didn't have it like this way. I think I had originally just the end view of this piston as my front view, and then I had a side view, and then it wasn't too long that I realized, oh, it'd be better if I had kind of a side view as my front view section and get a section view as my right side view, just for detailing. It kind of just exposed itself as I was working on it. I was like, oh, this is a perfect part for a section view. Then as I got into it, I'm like, it's pretty small. I like the scale that I just need a little detailed view of for the snap ring grooves there. So that's what I did here is I did a detail view. And so I didn't do this on camera either, but it's just a matter of, I'll do a quick little one here. Just right next to your section view on your place views tab is detail. And we didn't do any of these, surprisingly, we didn't do any of these in CAD at all. And that's all right. But you actually in mechanical drafting use the heck out of the detail view. Like I think it probably more than section views or between section views and detail views, you're going to do a ton of them. It's very unlike it's with mechanical parts, just like this part. I just can't see it well unless I blow it up. And that's what I've done here. So detail view I've selected. It wants to know which view I'm going to detail. I chose this one. I'll do the right side of it. It's going to automatically, pick my next view identifier. Says it's going to be D. It's going to auto do like a 2-to-1 scale, which you can change later. It doesn't have to be. It's like you can edit the view scale if you don't get it right. So I'll just let it do its default thing. The fence shape can either be circular or rectangular, and just some parts are better rectangular than this one is a better circular like cut window for sure. But rectangulars are handy for like long parts. And then I can either have it a nice clean cutout this is like what it's going to look like in my shape here. Like this is like the jagged cutout. Or you can make it a nice clean cutout. And I probably more often use the jagged cutout. It kind of breaks that up and makes sure I just know that it's a detail view or a partial view of something. Um, and then whether it's going to be hidden or and our detail views fall into that section view, which is section views generally don't have hidden lines unless there's a good reason to expose them or need them for clarity. But otherwise, they may add a little bit of information I don't want. So it looks like it's already pre-selecting to have the hidden lines hidden or removed. I'm just going to say okay. Oh, I've got to actually select. Let me go again. Detail this. So this is all applying now. Now it wants me to actually do something with it. So it knows it's this view. And of course I can change this, but all you have to do is click somewhere. I think it clicks from the center out with the circular one. So if I just click like, oh, I'm looking like here's my center of it, and then I start pulling out. Here's my little here's my little, and I have a place to like put, this is all movable later too. So I don't have to have this, I don't have to have any of this right. I can just get an idea. Oh, it's going to be like this. Then it gives me that view, which I placed over there, of course. I'll just place it over here for right now. But it's super modifiable. I can come in here to the outside edge here and just like stretch this thing in. If I took too big of a scope, if I didn't hit it where I want it centered, I can move it around. And if this thing is getting, interfered with other line types, pretty common that my arrows might, but I try to keep, like you can see when I place one, I try to at least keep the identifier free from being like buried like this. This is like just clean work. Like that is better. Yes. I mean, I could shrink that down a little bit too. And then I just jumped over here and went to town on dimensioning it out. The other thing I added though was the center line. You can see that the way I'm basing my how to locate these grooves are I'm using the center of I could pick the center mark, annotate. Here's center. I know it's buried, but I think I just picked the center mark, unlike this bore or something. And there's the center. That's at least the center mark for it. And then I drug it out. We're looking for that 0.25 extension. I think I drew it up a little bit like this too. And then I had a place to dimension, one side of the groove to the center, something like that is what I dropped in there. I said 2 times because I do have 2 sides there. Even though I'm only detailing one side, it does apply to the other side. And then I picked one side of the slot to dimension to, and then I just picked the slot width. And that's as far as I dimensioned. I didn't dimension to the other side of the slot. Slot width is driving that. The groove, I should call it a groove, not a slot, but the groove. So I only added a couple dimensions. Yeah, it might be arguable. Should I dimension it off of here? And yeah, there is some dimensioning that I have done there for that, like 0.75. I've already kind of captured. I view this as more of like the center is controlling this part for sure. This I don't view as really pulling from bottom to center. I really view that, just the overall diameter is 1.5 inches off center. It's 3/4 each side, so it's equally split. You'll see sometimes these dimensions are dropped if it's clearly showed with center lines. Could be the case here. It was always that debatable thing in CAD as well. I know I showed the width. This one I like better to have at least one of those dimensions. I'm coming off center to this side, and then it's 5/6 wide here. So it kind of gives me a center controlled dimension grouping. And then I have a wall thickness, right? Yeah, that's one thing that I had to add here. Is it does have so this is a great place for it's the typical wall thickness. So that's because we shelled it at 0.1. And so everything in here is 0.1 wall thickness. Yeah. I haven't like you can change the section type as well. I didn't, I just let it be default, which I think is like cast iron, but it works for generic stuff as well. So I never changed the sectioning, but you can. And so I'm not going to actually have this one myself, but I just wanted this one here. I probably had to change. I think my view, like I could tell when I did that, I should have left that up for just a minute. In fact, let me undo that. You can see that I have some formatting that could be done here because these two text styles are not technically ASME standard, and that's okay. Like I'm not. I think we can refine our template in a week or two. But I think these are dropping correct. This is if I click into this. This isn't where I modify what's in here at all. This is just gives me some information on what how this was set up here. Really, this is all coming from iProperties, and this is coming from the view label itself, or like this. The view itself, like if I right click here and go to edit view, the view 22 is just right here, is where it's picking that up as the view identifier. That can be changed, but that's just the way it's currently formatted. But what I was going to see is like if you have a view label that's incorrect, like that one would be, you can spot change it. This isn't what I'd want to do. I'd like my template to be fixed, but what I'm going to do is I'm going to highlight this word. That's 2.4. That's the correct size. Like ASME likes a 0.24 large. They call it a large style text for view labels. And then underneath it should be 0.125 as ASME standard. And these are kind of mixed, maybe it looks, but they should be 0.125. I think they are. I just don't think it's showing up that they are. It's just that when I drop my detail, I need to go into the formatting of the sheet and fix why my detail view. And I think I had to fix this one. I think my sections and details are probably not coming up with the correct text size. You'll have to verify that for me, but and then this one should be 1/8 of an inch. So really, once I dropped my view here, I did have to go in here and spot change just the text height. If I'm thinking of ASME standard, it would be 0.24 on the 0.24 on the view label and 0.25 on the other text type. Like that is technically ASME standard. That's one thing that I've noticed. Welcome, Sky. Is that I have a few formatting things to fix, but I'm not stressing out about them too much. So, like if you can recognize them and change them, that's fine on maybe your sections and your details for a week or two, and then I'll see if I can't get an updated version, updated to Canvas. Bigger thing that you can recognize that there's an issue. That should be where we're at, and figuring out how to fix it in the template and in Inventor, that takes a little bit of Google searching probably, but the answer's out there. As a drafter, we should be able to recognize when we need to be in a standard and when we don't. And you'll probably go work for companies where it's a different, potentially a modified standard from ASME. Okay. Wait, do I need to? Are you in actually?
Yeah.
Oh, I didn't even stop. I didn't even stop sharing, so I don't know why you're able to get in. That's good though. That's interesting. You've got Miracle. You got Miracle. But I do need to change. That's just me kind of doing some refinement on the drawing itself. Now I just need to open this part, open it. So I open my parts a lot here, a lot. This is how I open my parts a lot. It's just be in the drawing, select one of the views of that part. It'll open my part. So this one I haven't changed the tolerance of, but it needs to be. Sorry, let me get this fixed. If you ever double click these bottoms, I think we were talking about this last week. If you ever double click these, it goes to everything you have open, kind of. This one didn't go to everything I have open, but you can just hit maximize the one that you actually want here. I'm going to switch order here. I've already changed it. This properties to plastic. I've updated the description so it shows up the right description in my parts list. I just need to refine the through bore, and it will be the same as that hole we just put in the piston case. So I'm going to find where that hole is. Right there is my extrusion. I'm going to edit this sketch. F7, right, to cut to graphics if I need to. Sorry. F7 is where I actually drew this at, halfway mark. So this has this one has the original dimension, but 3/4 of ½ inch is 0.375. And then this tolerance didn't end up being good enough. It was too tight. So 10 thousandths works good though. 0.1, sorry, 0.01. 10 thousandths is what I'm adding to this dimension. Then I'll finish that. And now this will update on my drawing here. And I just want to change that dimension to show that oh, I don't even have it listed. Good thing I changed it. Now I can actually size and locate it. I kind of have it located. I just need the size. So I'm missing a dimension. Good. That's why you do these things. Wherever I want to come out, somewhere that's in my, like that. Sure. Oh, do I? Oh, yeah. I probably have it rectangular. Thank you. Okay. Good. Delete. Do I have it right here? Yeah. And that's smart. Hey, because I actually ASME'd this thing a little bit. That's where I want to do that. Where it shows rectangular, right? That's kind of the ASME standard. Circular things in their rectangular view. That's correct. This is the one that I want to update. And that's why I chose to put the dimension right there. Yes, it looks pretty normal. Just point to it and go. And I would do that if I didn't have a section view. Yeah, good. So I just need to go to like 3 decimal places, and it'll capture my actual size. I think the rest I'm just going to leave at 2 decimal place. This one I did catch in the circular view here. When you do that dimension, Inventor's smart, so it might recognize this as a radius. It does. But if you, I think before you drop it, if you right click and you can do dimension type and change it here. So that's what I have done. I've gone in here with my dimension, selected what I'm dimensioning, pulled away. If you left click, I think I can still change this, right? Even after here. I can say dimension type is a diameter. Technically, it is a radius, but maybe I just want a diameter to display because it's the inner diameter of the piston. I think it's arguable that either one could probably be okay, though. It is a portion of a circle there, actually. So, except for out on the very end right here, it is like kind of, it would have accepted that. If it was a true end view of that, it would have accepted that as a diameter. So, I changed mine to diameter. And then I think that was it for that little part. So I've got that one modified, dimension updated, kind of like my view label sizes. Maybe I could tuck this in a little bit. Maybe I can switch this underneath. Let me check the view labels though, because those are all supposed to be 0.25. Let me check this. I don't know if I can change this size. Yeah, right here, I guess I can. Technically, these are supposed to be the large size text by ASME standard. So that's another. I can tell I just have. I need to go in and format the specifically the sectioning and detailing text size for the view labels. Because ASME would want those to be 0.24. This one too. So I'm just double clicking in here and getting the actual. Remember when it's grayed in that box, it's pulling from somewhere, and more than that, this shows you how it's actually pulling it. If I just stop here for just a minute, yes, it's kind of like a Word document in some ways, but this is like it's in the view label properties. The source is this piston, and its property is the view identifier. But I can change. So this is how I could change something. That's why this is grayed out, because this is where this is all these three things are where this is pulling. So if you just want to change that in some of these, it's a matter, and this would be just a local change for this particular dialog box only. And to actually format, it's going to be in a different area. If I want to format my drawing template, it's different than this. This would only just do a spot change, kind of like we do on dimensions with precision. So I would probably not do this here to make that change unless, yeah, I'd want to go to the format area. Okay, I like this. What's that? Like these things here? Yeah, I just grab them. They have a bunch of grips.
Right on top of the line.
Oh yeah, the one that me like this is this corner grip is the one that actually I feel like I can move up and down, but um you may try to maybe move it a lot more than you want to move it to try to get it to move. If you're trying to do this a little movement, maybe it won't. Still no? Yeah, I'll come after I get this done and see if I can help you with some of that. Because the long story short is the formatting on the template is not actually dialed in perfectly yet either. So, but those two parts I'm happy with. I'll jump over to my next sheet and finish up a couple of these need tolerance as well. Nothing really with the wrist pin and that. Those are good. I changed mine to accept the big, like easier to apply, and that worked great. So, I did use that, not the snap ring there, but it kind of functions like a snap ring, but it's the one you just slap on there, and you can insert it from the end of the piston. It was way easier to assemble. That was a good change. Of course, the grooves on those are different than the grooves for these ones here, right? And that was me following the documentation that I pulled off from MasterCard. It gave me a groove width and a groove diameter, and that's how I modeled mine. So I might change the accuracy of the actual pin diameter as well. If I think of I'll just start with this part over here and work it. Definitely the critical part on this is going to be that hole that we've changed the size of. So I'm gonna open up this part too. I changed it to plastic already. I've got my description. I just need to change the I keep doing that, but I want it right there. Just need to change that probably one area of mine. I think I built this similar to how they did in the book, and so these are all equal constraints to the other end here. So this is the only one I have to change right here. And it's 0.75 or 0.375. It's a 3/8 pin plus plus a different tolerance though. 0.010. Hey, I got 10 thousandths the first time. That's the correct dimension. My other one is following that, and this is part is duplicated. So, yeah, that's kind of why it is 10 thousandths more than 3/8. Sorry, I'll get to it eventually. So it ended up being um the shaft size, which is 0.375 plus 0.1. 0.1? How about 0.010? 10 thousandths. For both of those holes. Yep, my hole's through there.
Same hole.
Yes, every hole that I needed the shaft to fit through, I toleranced to 10 thousandths over the shaft size. Except the one that you missed just briefly was the piston case. Open. Sorry, I'm in my. So for my piston case bores here are 15 thousandths over. So they're a 0.015. And it's because that longer bore, it's just a little, I never tried one at 10 thousandths actually. I just did one at 15. I just kind of guessed. It's got a longer bore. I'm gonna go 15 thousandths. I think I measured the one that I sanded on a little bit, and I kind of got an idea that where I was at, and that was just a great guess because I just did some really light sanding on the inner board, just kind of some because when 3D printers print, they can leave a little roughness. So I just barely sanded that. I barely sanded the outside of the piston a little bit, and it fit in really good. So. And you are right. Nathan was telling me, yeah, or he was just saying sometimes, if you go too sloppy, it actually doesn't make it work at all. It actually works better with being just snug a little bit. It actually functions really well. It's a little harder to turn, but actually I can feel that it just feels like the tighter tolerances or, too sloppy tolerance is not your friend always, is what it lets your parts kind of jam and get funny. They don't align right. And it was true. So a little bit of snug fitting was good.
So, are the,
Yes, going back to the connection rod. Here it is. And mine is just the only dimension I've actually changed from how I sized it all down was this the through hole to 10 thousandths over. Yeah, because originally we were what 475, and I just times that by 3/4. I mean, if this length was off a little bit there or here or there, it would be critical in a real operation. For us, we wouldn't notice it, but what it would do is it wouldn't push my piston as far as the other one potentially. Like I'd have a different, like if those dimensions needed to be refined, it might just be how far the piston pushes in and out of the bore, the cylinder, which is really critical in an engine. But it's not something we've really analyzed. But so I didn't add any tolerance to that or even the outside radius. I did change its type though and updated side properties. And so now I'll just update its drawing dimension mostly. This one right here, right? Yeah. This one here I want to change to 3 decimal places. I'll just leave the rest at 2, even though this might be a conflict. Is it though? I don't know, 16.2. No, that's actually that. Those check out, but they're probably. Yeah. Then I'll go to this part. And really the only thing I want to do here like maybe in my video I show you that you have this chamfer command, right? And I try to use these feature notes as much as I can because they'll simplify your drafting and your modifications that you might have to add. I mean, 2x's I have to go in front of, when you drop those dimensions, like you would in CAD, you drop that dimension. It opens up the dialog box. Usually it'll be whatever tab you were on last. Just cursor over, do my old 3x. Don't delete that gray thing. That's just picking up what the actual model dimension is. But yeah, I don't really need that one, but that's how I'm adding my 3x. Got it. Just delete it. And if you use chamfer, so I haven't wrote this out. I've let the computer do this, or I've just let the program do this for me. Chamfer is kind of weird, but I do think I do this in the video, where you pick the chamfer, and then it needs to know like what in relation to what is the chamfer. So I could pretty much pick this one or this one. You might, well, if you pick one or the other, it might not give you the right readout. Like mine is a 30-second chamfer, like a uh, 0.03125, I think is what my chamfer is. So I think if I pick these two, I end up getting the description correct. It's a 0.03 chamfer by 45. Then I had to add 2x in front of it because I just pointed to one over here and it applies to this one over here. But I think if I pick the wrong way, so it just takes a little trial and error this way. And if I pick this one, I think it works good. Yeah. Sometimes if you pick the wrong reference point, you might get the wrong. Just read out, make sure you don't just assume that it's right. Like read it when it applies it, make sure it's what you're expecting to see there. Um, I just kind of tucked mine in weird because of my drawing view here. These ones I'm going to take out to 3 decimal places though. So I'm gonna push this one out to 3 just because it's my actual rod there. And then I'm going to copy these properties and I'm going to do this one. And I think I'm going to do this one over here too. Now that shows the actual pin diameter. I think that's all the changes I'm going to make here. So um, I've had to add my center lines. I haven't adjusted their line type scale or anything, and I think we'll worry about that later. But you can see my line type scale could be adjusted here. I have a center line, but it's just not breaking up, and maybe these are breaking up too much. That's also something I could, in my template, I could set up. Of course, it would vary if I had big parts and little parts anyway, a little bit. So I think we'll worry about that a little bit later. Maybe wait for me to do some updates done. So I think that was it. Now I feel like my parts are, that's all I really needed to actually get them tolerance. Technically, these should print and be good. And so I think if you save this, and this is what you can turn in for an assignment, get a few sheets done, detail your parts, make sure your text boxes are filling out how you want them to fill out. You got your name on it, right? So this is the I properties of this if it's not populating. This is the I properties of the sheet, which has some data to put in. You're the author. I think if you put in you as the author, you'll end up populating the drawn by boxes. And I put rev 0. And I changed today's date, or this is the date that I did mine, but I just toggled that date. And I don't think I did anything else with the status custom or, yeah. Then the other thing to note is that I do have snap rings on here and stuff, but it's pretty typical not to have to detail out buyout parts. So I don't even show a view of them or anything. They're just called out in a parts list like this so they can be ordered. And I kind of show where they go on. I mean, there could be some sense if somebody really didn't know that I need to really like do some detailed shots of the assembly, or I could even make one of those exploded view, those presentation view assemblies to show someone, that if I had to really go into that level of detail to show someone how to assemble this. That could be an additional sheet. I wasn't going to add one here at this time, but that's not a bad idea. And then what I would say with this, like if I thought of like a library system, or if I thought of like checking this into kind of my work server or whatever, I might be working on my local drive. I might need to save this on their server for other people to access it or whatever. I would probably save it in its folder. I'd want those PDF documents that came from McMaster-Carr. Like I would make sure I, turned mine in. Oh, and then I'll do this. I don't know if my assignment calls out to turn this into a PDF, but that's what we would normally do anytime we finish a drawing is make it so we get shareable with a PDF, right? And so let's do that. And I can change my assignment just to say, hey, upload your PDF as well. And so that's just an export property here. So if I go to file and go to export it, export as a PDF is one of your exports that you can do here. So I'll say export as a PDF. Mine is a multi-page Unfortunately, I think this is more of a Windows to Inventor thing here because it's kind of more of like a Windows dialog box in some ways. But it's always, I think the default is to only do the current sheet as the PDF. So whatever sheet you're like highlighted on, mine is my first sheet, but it's only going to make a PDF of that sheet unless you go to options here and you toggle on all sheets here. Otherwise, I think default is current sheet. But and once I've done it once to my computer, I think it stays as that unless I come back to current sheets. But so this is how I can share somebody one sheet or share all my sheets. Um, Here's a little print excluded sheets. I'll go back and show that though. Print all colors is black. Um, Mine are all black anyway. So I'm gonna say okay on this, and then it should. Oh, it wants. I think it. Um, yeah, it just put that in whatever it doesn't give you a very good disclaimer that anything's happened, but it did deposit that in that folder. Let me do that again. File, export to PDF. Um, I'm actually looking in the folder where I'm going to save it. Right. So right now you can choose a different folder wherever you want to save it. I put my PDFs. I keep them the same name as my drawing file name specifically, so that in any file folder structure I should have the inventor drawing right next to the PDF. I think. And if you keep them the same name, that's how you can keep them in the same folder. And they'll generally be right by each other. So that is the name of mine. If you haven't, so I did pick a name that matches my assembly name, I think. Yes, same. And then when I hit save, hit those options, all sheets, hit save. You will have it there. It doesn't automatically open it for you though, but if you go find that file, or find mine, it is in week 3 in my V Twin. It's in class. Yes, someone I made a PDF. So this is my folder. It gets kind of busy. There's my V Twin Piston as a PDF. Here's my tool. Mine opening Adobe. Yours might open up with a web browser, but yes. We go back to Inventor. Some there are reasons why sometimes you have sheets that you wouldn't put as part of a normal print pack. You might have cut file sheets that we do. Well, cut file sheets go in there. What do I think? There are sometimes I have some supplementary sheets within my drawing packet that I don't necessarily print as part of a print pack. I mean, it's kind of a rare, weird thing. I'm trying to think of when I would do this. I know sometimes I would do stretch out patterns, and so that's like piping coping patterns. That's when people need to cut pipe for special applications. I can kind of give them a flat pattern, and they can I wouldn't anyway. Maybe we'll get into this when we get into some structural steel in mechanical structural steel, but yeah, there are reasons why I might have some sheets that I don't want to just print as included with the print pack that gets printed, and so that's why when you go in here, if I go into the actual sheet that I'm on, and in this where I edit the title for my sheet or the size of my sheet, you can actually toggle on exclude from count and exclude from printing, and that's going to, even though the PDF, if I check this box, this sheet will not print with my print pack. And then sometimes I don't even like those numbered either, because I don't like it to affect my numbering order. It's just this like extra sheet that I use to actually make like coping and piping. Like sometimes there are some cut files that you just like with pipe copes, they're weird. And you actually cut them out of paper and you just make a paper template that wraps over the pipe, and then it's like a fabrication technique. I'm trying to think if there's some other odd reasons why I would exclude a print from a print path, but just so you know, you can. It's just definitely a normal function. If I check that in here, it also can be really annoying if you're working with somebody else's prints, but that one page is not printing. Sometimes you just need to go in there and maybe something has accidentally been toggled off not to print. And so sometimes getting your PDFs with the right sheets in the right order, just pay attention to that. Oh, and that's my biggest word of advice is always go and open up your print after you've saved as a PDF and preview this thing, right? Don't just send somebody that until you preview that. Because a lot of times you don't catch your mistakes till you look at them here. And of course this allows you to email someone a lot easier, a part design or something, or approval drawings. They don't have Inventor, make them a PDF. This is how I'll turn in my drawings. Excellent. So I think that's all I wanted to really cover. Let's take like a 5 or 10 minute break. And then jump into the next assignment. Heck yes.